The Boeing X-32 was one of the most unusual and distinctive prototypes ever created for a major fighter competition, developed for the Joint Strike Fighter program that eventually produced the F-35 Lightning II. The X-32 represented a radically different engineering philosophy compared to its competitor, the Lockheed Martin X-35. Designed to meet the needs of the United States Air Force, Navy, and Marine Corps in a single platform, the X-32 attempted to combine affordability, modularity, stealth, and advanced avionics while delivering the high performance expected of a 21st-century multirole fighter. Although it ultimately lost the competition, the X-32 remains a fascinating example of experimental aerospace design, notable for its bold approach and innovative solutions. The most immediately recognizable aspect of the X-32 was its unusual appearance. The aircraft featured a wide, delta-like wing blended with a bulbous fuselage and a large chin intake beneath the nose. This intake was intended to simplify manufacturing and reduce weight while supplying sufficient airflow for all flight regimes. The aircraft's overall shape was optimized for low-cost production, using fewer complex curves and fewer structural components. Boeing sought to deliver an aircraft that combined stealth shaping with manufacturing simplicity, believing that affordability would be a key advantage in the JSF competition. Despite its unconventional look, the aircraft incorporated radar signature reduction features such as internal weapons carriage, aligned edges, and composite materials. Powered by a single Pratt & Whitney F-119 derivative engine, the X-32 demonstrated strong performance characteristics during testing. The engine provided enough thrust for impressive acceleration and allowed the aircraft to perform short takeoff and vertical landing operations in the Marine Corps variant. For the STOVL configuration, Boeing implemented a unique direct lift system, using the engine's power directed downward through a lift nozzle combined with wing-mounted roll nozzles. While this system worked, it required significant structural reinforcement and proved less efficient than the shaft-driven lift fan approach used by the X-35. The direct lift system caused the X-32 to generate high thermal loads near the airframe and made balanced vertical landing more challenging. These engineering issues contributed to Boeing's disadvantage in the competition. In terms of flight performance, the X-32 demonstrated stable handling, smooth maneuvering, and reliable avionics during its test flights. Pilots reported that the aircraft was pleasant to fly and maintained good control authority even at high angles of attack. The large wing area contributed to excellent lift characteristics and efficient cruise performance. However, the very wing shape that benefited long-range efficiency created limitations in agility and supersonic flight. During the competition phase, the X-32 could not meet the Navy's requirement for sustained supersonic operation in the carrier variant without redesign. This forced Boeing to propose a significantly revised wing and fuselage layout that was never completed before testing ended. This redesign required major structural changes, raising concerns about cost and feasibility. The avionics architecture of the X-32 followed modern fighter design principles, focusing on sensor fusion, reduced pilot workload, and network-centric capability. Boeing planned to integrate an advanced radar system capable of air-to-air tracking, ground mapping, and targeting. The cockpit featured a wide panoramic display concept similar to what later appeared in the F-35, with a hands-on throttle and stick layout and helmet-mounted cueing as part of the future vision. Although not all systems reached full functionality during the demonstration phase, the design direction aligned with the broader goals of the Joint Strike Fighter program. The aircraft also featured provisions for internal carriage of precision-guided munitions, air-to-air missiles, and strike weapons. During the JSF evaluation, Boeing demonstrated both the conventional and STOVL versions of the X-32. The aircraft successfully transitioned from conventional flight to vertical landing, showing that its direct lift system was capable of meeting the baseline Marine Corps requirement. The demonstration also showcased stable hovering and smooth landings. However, critics noted that the aircraft's configuration required switching from vertical lift mode back to conventional mode before transitioning to forward flight, whereas the X-35 demonstrated a seamless conversion that better impressed evaluators. Another key factor in the competition was the Navy's carrier suitability requirements. The X-32 struggled to meet these criteria because the original wing configuration lacked the structural robustness and aerodynamic performance needed for carrier launches and recoveries. Although Boeing proposed new wings and modifications to address these issues, the JSF program prioritized readiness, low risk, and proven capability. The X-35 prototype met these expectations more effectively. Despite the challenges, Boeing emphasized several strengths of the X-32. It had excellent manufacturing potential, with fewer parts and a modular design that could have significantly reduced production costs for the large quantities planned under the JSF program. The aircraft's design philosophy centered around affordability without sacrificing stealth or mission capability. Boeing projected easier maintenance, simplified logistics, and lower life cycle costs compared to its competitor. The aircraft also demonstrated solid reliability during its flight tests with fewer mechanical issues than expected for an early prototype. The cancellation of the X-32 in favor of the X-35 was not a reflection of complete failure but rather a demonstration that even bold engineering approaches face trade-offs in major defense competitions. The JSF program ultimately prioritized the X-35's superior STOVL system, its better transition performance, and its more adaptable aerodynamic design. The X-32, though innovative, would have required major redesigns to achieve the same operational versatility. Today, the X-32 remains an important part of aviation history. It represented Boeing's attempt to rethink fighter design with new manufacturing techniques, simplified shapes, and a cost-focused approach. The aircraft serves as a reminder that innovation does not always appear sleek or elegant. Sometimes bold risks lead to unconventional solutions that push boundaries and expand engineering understanding, even if they do not win contracts. The X-32 also demonstrates how complex the balancing act is between performance, stealth, versatility, and cost in modern fighter development. Although it never entered service, the contributions of the X-32 helped shape future thinking about aircraft design, affordability, and multi-role capability. Its place in the legacy of experimental American fighters remains secure as an ambitious, forward-looking prototype that almost became the next frontline fighter of the United States.